Right.
Let's bring Mario on the screen like right away because we are already over time. Hi Mario, how are you?
Hi, good morning or good
Good morning.
lunchtime or whatever. I'm okay. I'm a bit cold, so I'm wearing a big hoodie, and maybe I can get some time in.
Do you? I see your slides already here, so let me put them onto the screen, and we'll give you the show. We give you the stage right away. So,
Yeah, okay. Give me a second. So here we go.
oh, there was Chris's one. Let me
Right.
put.
No,
Yes,
wrong
we have
one.
them on, and the show is yours. Go ahead.
No, we don't. That's Chris's ones, isn't it?
Oh,
Those
put
ones. I
this
just put
one.
them on.
Yes.
Who's pressing the buttons here?
I'm
Right.
sorry. I
So
was pressing the button twice. Go ahead.
so everything good, right? Correct
Absolutely. Go
slides.
ahead. We have it.
Excellent. So, hi everyone. For the next, let's say, 20 minutes, maybe it's only 17 minutes, I'm going to talk about how you can continuously test and security test your OpenAPI based microservices when they are deployed on Kubernetes with a cool technology combo. I think this is a really cool combo with a tool called Testkube that allows you to run the tests inside of your cluster, and a tool called ZAP, that's a Z attack proxy that is capable to run vulnerability scans, so dynamic scans onto deployed microservices. So quick intro on myself. My name is Leander, principal software architect. I work for a German company called QAware. Our headquarters in Munich. I'm sitting in the very south of Germany. Almost, you see down there, those are the Alps. It started snowing today, so it's really cold right now in this room where I'm sitting. I'm responsible for many big projects in our company, for many customer projects. We do individual software development, for example, for BMW, so that large car manufacturer in Munich. And well, security is something that should be really important, right? In 2022, we had quite a few incidents over the last months where it kind of struck us and we had to react really quickly. But to tell you the truth, even though we had those incidents, I still think that holistic security in software development still seems to be a bit of a neglected non-functional requirement. In many projects and many agile teams, I do consultancy a lot. I see a lot of customer projects out there, and yes, the developers are kind of aware that security is important, but for some reason they don't do anything against it. So let's try to find out why that maybe is the case. And well, this slide you probably have seen or in other talks. So there's an ISO norm 25010. It's about software product quality, and in that ISO norm there are a lot of entities, right? Maintainability, efficiency, functional suitability, usability, reliability, portability, compatibility, and security, and maybe a few other entities already missing: operability or observability, things like this, right? More modern entities. So the thing is that security is unfortunately one of those several software product qualities. And well, as a team and maybe as a product owner, you always kind of have to decide which one is more important. And for some reason, right, I don't want to judge that, but many product owners, for example, they think functional suitability is definitely more important, right? They want to have the proper and correct and appropriate and complete software product. That's their main focus. And if you would ask a software administrator or an ops person, that maybe reliability and efficiency is maybe in their prime scope. So I think it's usually dependent on who you ask, which of those software qualities gets the most attention, right? And security is kind of a feature, right? I mean, security is also important for the product owner and also for ops people. But for some reason, right, this is a lot of work involved here. You need to do a lot of testing. You need to do a lot of security testing, a lot of acceptance testing for the functional suitability. For reliability, you maybe need to do chaos testing. For maintainability, you need to do software code quality testing. So this is a lot of work, and well, unfortunately, security usually comes a bit short, and that is, that is sad. That is a tragedy. Then I'm really sure you have probably read that book here, the Accelerate book, where they kind of argue that what you need to do for continuous delivery, and on the right-hand side, you see all those benefits of continuous delivery, low-risk releases. Yes, we all want them, and less rework, and we want happy teams because happy teams produce better products, and we want fast time to market and lower cost and happy users in the end. But as it's always said, nothing is for free. You have to do a lot of things to get there. There are a lot of tools and techniques and technologies and paradigms and whatever that your teams need to cater for. They need to handle those things. Loosely coupled architectures, aka microservices. They need to write maintainable code. You need empowered teams. That is a topic on its own. Continuous security from day one, it says in the book, right? So it starts with the requirements, the security requirements. You need to do secure coding, and you need to incorporate security into your daily into this software product delivery chain, if you would like. Test automation is important, continuous integration, GitOps, deployment automation, monitoring and alerting is so much to do, okay? And I think a lot of the teams out there, they're just overwhelmed. This topic of cognitive load, they're just overwhelmed with all the stuff they have to do. And, the hard parts usually are then the ones that are kind of probably neglected, right? And let's see how we can kind of get out of this dilemma. Now, what many teams now do is, what do they do to kind of automate things? Well, they build pipelines, right? We have those CI/CD pipelines. I mean, that is kind of an era on its own, doing like two things. CI is something different to CD, but nevertheless, we always talk about CD pipelines. And what I see out there is that many teams, they start to build those monolithic, kind of linear CI/CD pipeline, but they're super suboptimal, and they will result in delayed feedback and long release cycles and all those good tests, right? The security tests, those dynamic tests, the performance tests, the acceptance tests, they're kind of super late in those pipelines. They are usually reside in kind of flaky pipelines, in long-running pipelines. So what do people do? Well, let's not integrate it into the pipeline. Let's take it out. Big promise. We will do it at the end of the sprint or at the end of the release. Then we do our security tests. But guess what? Then usually they are forgotten, and well, they're not run those tests. So I had that idea. So how can we improve on that? If it's not such a good idea to put these into those pipelines, well, let's see how we can kind of let those tests run. And the simple question is, why should we let those non-functional tests, or in our case today, the security tests, why couldn't we run those continuously, or maybe event triggered based on deployment events on the cluster itself, so that my CI/CD pipelines, they don't have to run the tests. And instead, it's the cluster itself that runs those tests always when things changes, or maybe on a cron basis, maybe every 2 minutes, maybe every 5 minutes, so kind of continuously. Or as I said, triggered by some event, by the deployment event, by your GitOps tool maybe, or by Kubernetes events itself. I want to introduce you to something what I call the digital product assembly line, right? I worked for the last 14 years in kind of different projects in the automotive context, and if you've been in one of those factories, everything is super automated, right? The chassis comes, and then all those robot arms, plug in the engine and the wiring, and they paint it, and the windows and all that. And I think software engineering should be, or software product development, digital software product development should be as automated as possible as these factory assembly lines. So here's my pitch. Okay, so let's split things up. How would the conceptual architecture of such a product assembly line look like? Like, this here is not something new, hopefully, right? I mean, we have devs, they write code, they push code into Git repository. Then I have some form of CI pipeline, maybe GitHub Actions, or maybe a good old Jenkins or something that does the checkout, that then maybe, or that does the build, maybe with Maven or Gradle in a Java world. You have some unit tests, some early unit tests, maybe you have some early test container tests. You do some static code analysis, maybe using SonarQube. At that stage, you could already incorporate static security analysis tools. There are lots and lots out there. At the end, you have then the final packaging phase, where you package up all your artifacts that you just built into a nice, cuddly Docker image. And then the next phase is, well, you publish that Docker image to some repository, right? GitHub Packages, or Amazon ECR, or maybe a Nexus repository, something you like. Again, here, you could have some tool already in place that maybe then already scanned the Docker image for known vulnerabilities and all that. Right, so far so good, nothing new probably. Then you have, or you should have, we've seen in the book, you should have some GitOps workflow running. So either you prefer Argo or you prefer Flux. Today I show you Flux or I use Flux. Flux will watch first up for a GitOps repository to know what has changed, what needs to be deployed on the cluster. Flux can also watch on the package repository. When there is a new image, Flux will also already update those manifests and then finally deploy something to the cluster. So now I have something deployed. Now I have that event I talked about before when I can now kick off those fancy performance tests or acceptance tests, or in our case, security tests. And this is basically what I will show you right now in a small demo and with a few details. So I said before, two really cool tools. The OWASP ZAP attack proxy called ZAP and Testkube. So let's see. Now everything I show you is in that demo repository here, which is my private GitHub repo, Testkube ZAP demo. Fork it. Please feel free to use anything you like in there. It's MIT license, so copy and off you go. So quickly, OWASP ZAP attack proxy. Well, I think it's pretty widespread and it's well known. It's an open source vulnerability scanner, super good documentation, international community, vivid community, still actively developed. ZAP provides several modes of operations. You have an intercepting proxy. You can do active and passive scanning. You can do an HTTP spider to kind of crawl a website. You can use a brute force scanner, a port scanner. Relevant for today is you can scan and then attack OpenAPI v3 endpoints, so good old REST endpoints. It even has support for SOAP and GraphQL, where SOAP is kind of the old style, GraphQL maybe the new style, and also WebSockets. What's really cool about ZAP, it has a really powerful API and a few tools that allow you to automate the security scanning, right? So that you don't have to click anything. So the automation is done by a few scripts in the one place, and they also have a few language bindings like a Java binding where you can interact with ZAP programmatically. Now, the cool thing for a containerized runtime environment is that ZAP provides an official Docker image that has everything baked in. Okay, so you only need that one image. And with that one image, you can do API scanning, you can do baseline scanning, you can do full scanning, active and passive with AJAX scanning. So in case you have kind of a web page, but the API scanning is really relevant for today. You even have a web swing UI if you want to have a fancy UI that you can click. Now let's quickly jump in one of those. Where is that UI I want to show you? So this here is kind of the web swing UI I just talked about before. So this is the basic ZAP UI. You could also install locally on your desktop machine, right? Basically, it's a Java program. But this now runs in a browser, and the deployed UI is already running in a Kubernetes cluster I just spun up, a few hours ago in the Google Cloud. And up here, for example, you have something called import OpenAPI definition from a URL. And now let's see. So that is the URL I will point in here, and you see that's a microservice default service cluster local. So that's the DNS name of a service inside my Kubernetes cluster, port 8080 where the OpenAPI definition comes from. And down here, we override that one. And just to show you, this is then you press import, and now he does the scanning. And now ZAP already discovered all the endpoints that my microservice is offering, okay? And I know I show you this manually now, but everything I do here can basically be automated, okay? So this is just to show you what I'm automating in like a minute time. So here, and basically what we can then now do is we can say attack, active scan, and off you go, start scanning, and now ZAP will attack my microservice deployed in my cluster, okay? So let's see how we can kind of automate things. Well, option number one is we could program something, and option number two is we could use Testkube to kind of do the job for us. So the automation, just to be complete, well, this is, for example, a Spock spec. So everything I just showed you in the UI can basically be done using that way here. So this is here, I create a new ZAP session. I say import URL, and down here, I say I want the API minimal scanning, and then I scan each of the URLs discovered in the previous step. So this is how you could kind of code your vulnerability scan using ZAP. All you need is kind of this either the ZAP daemon. This is here the Docker image I told you before. So this is kind of a headless daemon deployed where only the API is spun up, and my unit test or unit security test will then contact that daemon, and then the daemon will kind of do the scanning and the attacking of the microservice deployed in the same cluster. And that here is kind of the deployment or the part of the UI I just showed you. Okay, so it's a bit of Kubernetes YAML, no big deal. Deploy that to your cluster. Off you go, and you have ZAP running inside your cluster, and you can automate it from the outside if you have kind of a unit test. Okay, so okay, get NS. So this is here, for example. This is all the namespaces on my cluster. You see the ZAP stuff is deployed in ZAP, and now you see here that namespace is called Testkube. So let's quickly talk about Testkube. What the hell is Testkube now? Well, Testkube now is kind of a cloud-native testing framework for Kubernetes. Okay, so Testkube integrates this test orchestration and the test execution into your Kubernetes cluster. Okay, and it takes it out of your CI/CD pipeline or the GitOps pipeline. Okay, so we don't have any vendor login for test orchestration and execution anymore. So Testkube is completely decoupled from your Jenkins, from your GitHub Actions, from your GitLab Actions, whatever CI system you use. But the cool thing is that it kind of decouples the test execution from the build process. Okay, this is two things. Build process is one thing, do one thing well, and then comes the test execution. It also enables your test engineers, if you have some, to run specific tests whenever they need them. Now, Testkube makes it really easy to run those non-functional tests, like load performance tests and security tests and compliance tests within your cluster. Okay, and that is really cool in highly constrained environments where maybe the cluster is not even accessible from the outside. So all you need to code is your test, and then you tell Testkube, hey, Testkube, here is a ZAP test, or here's a K6 load test. Please execute that whenever something changes in the cluster. It's kind of a modular architecture, and for each and every test it supports, they have a concept called the executor. So what I will show you is kind of this here, okay? So that's kind of the demo architecture of the cluster I'm currently running. So I have Testkube deployed inside my cluster, inside a dedicated namespace in the cluster. I did the deployment using Flux, right? So also the Testkube deployment and lifecycle is managed via GitOps. It's a simple Helm chart. You can deploy in a cluster. Then you have a nice fancy dashboard, for example. You have something called the API server that you can interact with as a developer using the CLI, for example. You could also have a CI system trigger the API server to start with the test phase. The really important part are the executors, right? So for each and every certain test type, you have a distinct executor, like a ZAP executor or a Gradle executor or a K6 executor. And you declaratively define your test. So good old Kubernetes style YAML. Obviously, all those manifests can also be managed by GitOps. So test is kind of the smallest piece bit. Test can reference test sources. A test source is something like a Git repository, for example. You have test suites. Test suites aggregate individual tests, and you have test triggers that kind of are then the glue. Whenever a deployment changes, then run the following test. So let's dive into that demo here a bit more. So we kill that one here. So what does a ZAP test look like, the Testkube style? So to just give you an idea. So this here is basically tells, hey, dear Testkube, this is a test, follow the following name, add the namespace Testkube, type ZAP API, and then here in the data, what you need to specify is a few configuration parameters. This is basically all the parameters you could set in the UI. So maybe you remember, and this link I just inserted into this UI field. This is basically all the configuration that the test needs in here. So what you can then do is, for example, so to create that test, either you write that piece of YAML here and commit it to your GitOps workflow. Obviously, there's a nice, cool CLI you can you could also use to do exactly the same. Let's see what we have that one down here. For example, you say, so the CLI comes as a kubectl plugin. So you say kubectl testkube create test2, bam. So that one is now created. And if you would want to run that ZAP test, then, well, basically what you could either do here, down here, is you say kubectl run test. We do that, like that, watch ZAP API test, and then this will, start running. So that obviously now takes a while to spin up. We only have 2 minutes left, so I need to speed up a bit. So it's super easy to kind of tell Testkube now, hey, listen, with the following configuration, now do your testing. And now comes the final tricky bit. So this is this here, okay? So this is a so-called test trigger, okay? So this basically says, whenever there's a deployment in the namespace default that has the following labels like app microservice, so this is my small Java-based microservice, in case of a modified event, then please run the following test with the name we just specified. So we just changed those names here. So what we could do now is either apply that manually or have GitOps apply the stuff as well. So what we could do is kubectl apply -f K8s testkube, and then we have the ZAP API test trigger. So now, Testkube will watch for any change events on my microservice, and whenever my GitOps workflow now deploys, or those other pipelines deploy the microservice, then Testkube will automatically trigger the ZAP test once the deployment has changed. So every time something changes, I let the test run. There is also the possibility to let the test run using kind of a cron scheduled type test. Right. So I hope you believe me that this is a cool tech combo to kind of continuously let those those penetration tests onto your microservices run continuously on your cluster, and pull those out of the CI pipelines. And let the cluster do the work so that you don't have to do the work, and that hopefully you ship nice and secure microservices out there for your customers. All right, that's it. 20 past 1. Thanks for your time.
Awesome, thank you, Mario-Leander. I really love that. That's super cool. Again, we're slightly running behind again, so if folks have additional questions, I'm sure you'll hang around in Discord for a few minutes and just see who's got questions for you.